LDT, which stands for Laser Deposition Technology, is an additive process that is used to build free-form fabrications, repair metal components typically considered non-repairable by conventional techniques, or strategically add features to forgings or castings. All of these capabilities come directly from CAD data. No hard tooling changes are required. LDT deposits exhibit excellent material properties. These material properties, combined with the flexibility of the process, significantly lower overall production costs. When used for manufacturing and the production of prototypes, the LDT process greatly reduces product development time. First, a 3D CAD file is created that defines the component that is to be built. Next, the system software uses this file to slice the piece into numerous horizontal sections and then creates a toolpath for each layer. This toolpath is followed by the laser as the piece is created layer by layer. The build takes place in a controlled environment chamber with less than 10 parts per million oxygen. Once the chamber is prepared, the build can begin. The laser fires and creates a melt pool on the surface of the target plate. A stream of powdered metal is delivered into the melt pool. When the powdered metal impacts the melt pool, it is absorbed into the melt pool and creates a weld bead. Fusing multiple layers together generates a 3D solid metallic build. A variety of alloys can be used in this process, including tool steels, stainless steels, and nickel, cobalt, and titanium alloys. Deposit quality and consistency is of primary importance for all laser deposits. Being produced in a very low oxygen environment with a very small laser spot size and relatively high travel speeds, the laser deposits have extremely high cooling rates. These cooling rates generate a very small localized heat effect zone, thus minimizing distortion. Also, the high cooling rates result in laser deposits that have a very fine microstructure. Therefore, the deposits typically have improved mechanical and physical properties compared to